I'm not
What
sure.
kind of proofs are we doing?
Pretty simple proofs, yeah.
Okay.
Just like diagram and like proving the congruent.
2-column proofs.
Yeah.
All right. All right. I saw the email that you shared it with me. I saw an email come in, but let's see why. I don't know why I can't see it. Well, I said that it did share with me because I got an email, but now that I think about it, I may have got it. Yeah, I got it from I got it from a different account. I needed to be shared to napervilletutor@gmail.com, and it looks like you shared it to.
Yeah, I fixed it.
Oh no, this is
Because
Naperville
I shared
Tutor.
it to the science one before.
Okay. Well, this is a first that for some reason I'm not able to find it. I'm like, oh, there it is. Now it's there. Okay. All right, here we go. So this first question says, given that BD bisects ABC and the measure of that is 25, solve for X and Y. Okay, so this isn't a proof, this is a solve one. Now the fact that it bisects it means that these two are equal to each other, right? So we're gonna write that out. We're gonna write 2x minus y equals 3y minus x, because we know they're equal to each other. And they told us that angle ABC is 25, so we know each of those is 12 and a half. So let's see, what can I do? A little bit tricky here. So I can do this. Let's do it this way. Basically what I want is I want two equations with the two variables. So there's a couple ways you can do this, but I'm going to do it the most what I think is probably the most straightforward way. I know that this thing is going to equal 12 and a half, right? Because ABC equals 25 degrees, right?
Yeah.
And I know that 3y minus x also equals 12 and a half. Make sense?
Yeah.
In fact, I'm going to rewrite this as negative x because I don't like I'm going to write this as negative x plus 3y. It's the same thing. It's just I'm writing it in a better format.
Yeah.
Do you remember solving systems of equations? Remember what I have to do?
Yeah.
So I'm going to multiply this equation by what to eliminate the x?
2.
Perfect. So negative 2x plus 6y equals 25. So that's gone. Now let's add them straight down. The x's are gone. The 5 got 5 y's equals 37.5. So what does y equal? Divide 37.5 by 5. So I'll do that on my computer here. 37.5 divided by 5. Whoops, that didn't work. Backspace. 7.5, there we go. So 7.5 is my answer for y. Now, if I have that for y, how can I solve for x? What's the easiest way to solve for x now?
Plug it into the second equation.
Or the first. Probably the first would be a little bit easier. Right? Do you know why I can plug it into the first equation?
Yeah.
It doesn't really matter. You can plug it into either one, whichever one looks easier. So 2x equals, if I add that, I get 20. So x equals 10. So there's my x and my y. And you can check to make sure it's worked by plugging, but I'm sorry, to make sure it's right by plugging those into your second equation now. Negative 10, 3 times 7.5. That's 21, 7, that's 22.5 minus 10 is 12.5. Yep, that checks out. Good?
Yeah.
All right, next question. You say, given those prove, so you just want me to check this? You already did it, or do you need?
No, I
Do
didn't
you
get
need
the
to?
last one, number 4.
Okay, let me zoom in on this just a little bit more, so we can see that a little bit better. I guess I can't see it. It's not letting me edit it on my computer. This happened to me once before. I'm not sure why this happens, but for some reason, I don't know if it's the way it's shared, or are you using your school account?
Yeah.
That could be the reason. That could be the reason that we're having some issues with this.
Yeah.
When you use, for some reason, when you use your school account with Jamboards and you try to share it with someone outside your school account, it doesn't quite work right. So that's probably what happened. But so in the future, I would say if you have a personal Gmail account, just use that.
Yeah, I'll try that.
Okay. So let's see what you did. So given NOP is congruent to, so NOP is congruent to SRP. So those are congruent. Good, you've drawn that in. NOP is complementary to PQR. Is that what that says? NOP to POR. Okay. And this is complementary to that. Okay. So if segments are complementary to each other, then they form a right angle. Okay. So what are we trying to prove here? POR is congruent to PRO. Okay. Okay, so let me sorry, go back here and see where your SRP is complementary. Okay, so you know that these are equal to each other, and you know that those are complementary. Okay, so you're starting by saying that these are right angles.
Yeah.
I feel like there's a more simple way. Isn't there a property, or have you not learned it yet, that says that complementary angles to congruent angles are congruent?
I don't think we learned that. No, we did. It's like if two angles are complementary, to congruent angles, then the angles are congruent.
If two angles are
let me check.
complementary to congruent angles, then the angles are also congruent.
Yeah.
I just don't know if you've learned that yet to where you'd be able to use that, but that is true. I mean, you're basically proving it right now, right?
Yeah, if angles are complementary to congruent angles, then they are congruent.
There you go. So that's really all you needed to say here.
All right.
You follow what I'm saying?
Yeah.
So if you have that already, if you have that what is that called? A property?
Theorem.
Theorem. There you go. If you have that theorem already, then you can just apply it right here, I would say.
Yeah.
Make sense?
Yeah.
Not that what you're doing couldn't work too, but you're just taking the longer road. It's kind of like you're proving that theorem right here.
Yeah.
So you're saying that segments are complementary, and then you're saying NOR is congruent. Then you're saying that they're right angles, so they're congruent. And now you're going to say, then you would have to use the subtraction property right here for 4. Your reason for that would be the subtraction property, because you're subtracting congruent angles from 2 other congruent angles.
So instead of doing like 2 and 3, I could have just skipped to 4.
You could have literally just had one line, and which was the property the theorem you just told me.
Yeah. Okay.
Unless your teacher said, prove this without using that theorem, because this is essentially like that. This is that theorem.
Oh, okay.
You know what I'm saying?
Yeah.
You have, right? It's exactly that theorem, isn't it? Isn't it exactly what that theorem that you just read to me? Yeah, I think it is. All right, so let's do this next one, page 3. It says given EGF, so those are congruent. So I'm going to write these in. EGF, so this big one here is congruent to EFG to this big one here. And EGH, so this small one here, I'll do this, I'm color coding these. That small one there is congruent to EFJ, that small one here. Okay.
All right.
So they want us to prove that HGF is congruent to JFG. So they want us to prove the yellow. They want us to prove this. It's congruent to this. So this would be, you basically state your givens, and then you state your what they want you to prove, and it's simply the subtraction property.
Oh.
Because you're starting with the same, you're starting with congruent angles and you're subtracting congruent angles. That's the subtraction property.
Oh, okay. Thank you.
Right? That make sense?
Yeah.
So I don't need to write that up. You can, that'll take too long. Let's just do some more problems. Okay, good?
Yeah.
And again, this is being recorded, so you can go back and watch this again and write and listen to what I said and write it up as I stated. All right, so let's try this next one. It says if 1 is complementary to 3, so 1 and 3 are complementary, okay, and 4 is complementary to 2, okay. They want us to show that 1 and 4 are congruent. So what we're going to say first is that, so you go ahead and say you're given. Again, I'm just gonna kind of write it shorter, and you can clean it. You'll want to write it more carefully, but for the sake of time, I'm not. The second that you're going to want to say is that angle 2 is congruent to angle 3. And do you know the reason for that?
Yeah, vertical angles.
Perfect. So vertical angles are congruent. And since I have 2 and 3, what was that one property you just read to me that we used before?
The complementary to congruent.
That's right. Angle 1 is congruent to angle 4 because of that theorem that you just said.
Oh.
Makes sense? See how we come up with that?
Yeah.
So read that to me one more time and I'll write it out.
If angles are complementary to congruent angles, then they are congruent.
If angles are complementary to congruent angles,
then they are
congruent. Do you see how that's what I have here?
Yeah.
Because I have complementary, I have 2 and 3. 2 and 3 are, I'll even write it in here so you can see it. If angles are complementary to congruent, the congruent angles are 2 and 3. And the complementary angles are 1 and 4. Right?
Yeah.
So that means 1 and 4 are congruent. Let's try the next one. Page 5, number 6. Given VS is congruent to VR, so this is congruent to this. And then WT bisects VS, WT bisects VS and VR. So do you remember the relationship when you have a if that bisects them, do you remember the relationship between?
Yeah, if they're divided into two congruent angles.
I think I'm talking about side lengths.
Oh.
Isn't there a property that relates side lengths when you have a mid? This is called a
midpoint?
Well, no, this line is called a mid-segment.
Oh, we haven't learned about that yet.
You haven't? You haven't learned about mid-segments?
No, we've learned about midpoints.
So a mid-segment theorem, this is kind of an important thing. The segment joining the midpoints of two sides of a triangle is parallel to and half the length of the third side. I actually don't need that for this problem. I was assuming I would, but yeah, they didn't give us that distance. So I guess that doesn't really matter. So I take it back. We don't need that, but that's a good one to remember. That's called the mid-segment theorem. This line right here is half of this line. So this line is 3y. But they actually didn't want, they wanted the perimeter of VRS, so that actually didn't really matter. But I do know that this is also 2x right here. Right?
Yeah.
So I can just find x and y basically. So how do I find x and y? Well, I'm going to set this side equal. So y plus 5 plus x plus 4. That thing is going to equal 2x plus 2x. It's going to equal the right side, which I'll do in red, 2x plus 2x. Because it told us that those were equal to each other. I'm trying to think, could I have just said that 2x equals x plus 4? Do these things equal each other?
Oh, yeah.
I'm trying to think of why that wouldn't be the case. Because we already know that those bigger sides are equal, the VR and the VS. We know that that's an isosceles triangle. So I think all of these things would just be equal to each other, wouldn't they?
Yeah, because they're all
Yeah,
congruent.
so we don't even have to do that much work. We just can say x plus 4 equals 2x. Right?
Yeah.
We're just going to set these two equal to each other because those both have x's in them. Or we could have set these ones equal to each other, right? So that just means that 4 equals x, subtracting x from both sides. So x equals 4. And if x equals 4, then what is each of these? What does this side equal over here?
8.
And if that's 8, then what's y? So y plus 5 also equals 8, which
So
means
3.
y equals 3. So now let's just plug in our things. Plug in 3 for y here. Plug in, you know, this is 8 and 8 and 8 and 8. And 6 times 3 is 18. So it's basically 4 times 8 plus 18. So 32 plus 18, which is 50.
Oh.
Good?
Yeah,
Any questions on that one? Are you good?
I'm good.
Okay. Find the measure of angle of angle 1. Okay. So what do we know about these two angles here and here?
They're congruent.
So what can I write?
X squared minus 6x is equal to 1/2 x plus 42.
Good. And now let's just solve this. Now this is going to be tricky because it's a quadratic. I'm going to choose to simplify this by clearing the fraction because I just really prefer not to deal with fractions in here. And it's easier to solve them. So I don't know if you know this trick, but I'm going to multiply by 2, everything by 2. So this is 2x squared minus 12x equals 1x plus 84. Everything got bigger by double. And now I don't have to deal with fractions anymore. So now let's move everything over to one side. So minus 13x minus 84 equals 0. Now let's try to factor it, if it can be factored. You good with factoring?
Yeah.
2x and x. 84, let's see, 84 is 4 times 21. And right? 4, yeah, 4 and 21. I bet if I put a 4 and a 21, I bet if I put a 4 here and a 21 here, I might get 13. If I put the right negative and positive in the right place. because 21 minus 8 is 13. Huh? See what I did there? Do you follow? You get what I'm saying? So I'm going to make this a negative, and I'm going to make that a positive. Why? Because now negative 21 and positive 8 makes negative 13. So 21 times 4 is 84, negative, sorry, negative, and the inside and the outside make negative 13. Good?
Yeah.
Okay, so then just solve each one of those. 2x minus 21 equals 0, and x plus 4 equals 0. And so x equals 21 halves, or x equals negative 4. Now, does one of those not make sense? Or do they both make sense? Does negative 4 might not make sense.
Yeah.
But it might. It might make sense. Well, it doesn't really matter. You can use either one of them because all you're trying to do is find the measure of 1. So plug in negative 4 here, right? Plug it in there. What's 1/2 of negative 4?
2x.
No, negative 4 is your x.
Oh. So
Just negative 2.
negative 2.
And what's negative 2 plus 42?
40.
40. And just to make sure we did that right, plug in negative 4 here, and you're going to get positive 16. Plug in negative 4 here, you're going to get positive 24. And what do those add up to? 40. See, that's what you were doing. You were trying to solve for x so that you could then solve for that angle, which we just did. This angle is 40. And if this angle is 40, then what's this angle?
40.
Nope, this big one.
Oh,
It's supplementary, right?
140.
Yeah, 140. So M equals 140 degrees. Okay.
Okay.
Do you see how I did that?
Yeah.
It seemed like that one wasn't quite as clear to you. And I did do some tricky things there. Maybe
Yeah,
the trickiest thing I did maybe for you was I cleared that fraction because I don't like dealing with fractions. Could you deal with fractions? You could.
I tried
if you really want.
but then it messed me up.
Yeah, but it's not easy to factor with fractions, is it?
Yeah, it's not.
So clearing the fraction will make you factor with whole numbers instead, and that's what we're used to doing. So whenever you have fractions in an equation, you can always make it bigger. You can always make the equation bigger by just multiplying by the least common denominator, and then you won't have any fractions to worry about. You'll have bigger numbers, right? My numbers were bigger, 84 and 2x, which was a little bit of a pain, but it wasn't really that bad. And you could have left it as a fraction and then plug that into your calculator if your teacher lets you use calculators, and then you'd be able to find it with a calculator too. Up to you. All right, last one. Let's get this done. We got really no time, but let's do it. Draw the rotation of PQR 180 degrees clockwise about 0, label its vertices with their coordinates. So clockwise means I'm going this direction. 180 degrees means everything is moving like this. So this point is going to move all the way to here. This point is going to move all the way to here. And this point is going to move all the way to here. You follow?
Yeah.
So this point, that 7, 0 is going to be over here at, let's see, what are these each? 2. This is going to be at negative 7, 0. So what's the mapping for clockwise? What's the mapping? Is it negative?
Negative xy.
So xy goes to negative x comma y.
Yeah.
Is that right? So
yeah.
you could just do it like that too. So this point right here, which is negative 5, 0, becomes 5, 0. So that's 5, 0. That's your new That's your new P. So this is P prime. Is that how you label them? This is R prime. Yeah.
Yeah.
And then this one would just be 2.
2, 6.
Okay, hold on. I don't think that's right. Are you sure it's not negative x negative y?
Let me check.
Because this point should move like from here down to there.
Oh yeah, it is negative x negative
Yeah,
y.
it's negative x negative y. The 0 made it seem like it wasn't, but it was. So it's negative x negative y. So this point becomes 2 comma negative 6. 2 comma negative 6 is your Q prime. So there's your mapping. Okay. It says draw the slide along the ray PR so that P is at O and label its vertices with their coordinates. So let's do this one in black. Draw the slide of PQR along ray PR, along ray PR, so that P is at O. So they want us to slide it. It's kind of hard to draw this because I don't have any space left, but this, they want us to slide everything over so that the P is at O. So they want, basically they want to slide everything 5 units. So basically what we're going to do is we're going to add 5 to each of the X coordinates.
Oh.
That makes sense?
Yeah.
So that's your mapping. You just add 5. I'll let you do that on your own. And then the last one says draw a reflection. I'll do this in yellow. Draw a reflection of PQR over the y-axis. So over the y-axis means I'm going to take every one of the X coordinates and switch them. And I'm going to keep the Y coordinates as they are. So this point would go here. This is Q prime, prime, prime. Right? And then these ones would flip here and here. There's the yellow one. So 2 of those points were the same as the blue one.